Hi, welcome to Make a Repair. I've had one of these plugs. It's a little remote control socket powering a lamp in the house for quite a while, and I've actually been through two of these now. It's a pack of 4 that I bought, and this is the second one that's failed in exactly the same way, which is that I can press this button and it turns the lamp on and off manually, but when I use the remote control it simply doesn't do the switching. So the previous one went, fitted in another one, this one's gone as well. Now I thought what I'd do is take a look inside this, perhaps take a look at the build quality as well while I'm at it. And I've tried reprogramming this. It will go into program mode, but it simply won't respond to the remote control. So I'm suspecting that it's the RF side of things that's faulty. I don't think I'm going to be able to repair this. I think what I'll find is that there is a little antenna going into a little receiver with a microcontroller built into it, all as a little self-contained package. And the only extra thing will be perhaps something to drive a relay or something of that nature. I bought them because I thought they were probably pretty decent. So they've got a bit of standards marking on them. That doesn't really mean anything, of course, but it's a good starter for 10. And of course, the CE mark, which everyone just fakes anyway. We've got a fairly decent, sturdy box. We've got what appears to be appropriate connections on the back here. So we've got a fully unsheathed earth connection, which looks to be the right dimensions. We've got plenty of space between the live and the neutral and the outside world, and those of course are sheathed as they should be. And you know, that's mainly what we're looking for in terms of the actual socket section. I can see there are 3 screws holding everything together, one here, and one here, but these are partly occluded by this socket, so I'm going to have to figure out how to get into that. So it's going to require a bit of force, I think. Yep, there we go, central locking pillar. Fortunately, I haven't broken it, so that's all good news. Now we can get at the 2 additional security screws, and we should be in. Anyway, here we go. Oh, more on the board than I thought. So let's have a quick look inside. This, of course, is just our first glance at it. Fairly decent connections. The live in particular looks okay, I think, so far. Good thick plastics. That's always a bonus. I don't think that these are going to be fireproof, but you know, hey. Okay, so I've shot a high-res picture of the board so we can look at it in a little bit more detail. I'm quite surprised there's a lot more on it than I expected. I had expected a kind of modularized RF receiver with an onboard microcontroller, but in actual fact, they've built it all separately. And start off then, obvious, just here then we've got the switch and the LED that we can see from our front panel. And we can see the LED goes back through here, up this trace here and into the microcontroller, and the switch does a similar thing just here. This is obviously a microcontroller. I've had a look at the part number. It's an HS2300P. So it's low power consumption microcontroller, 8-bit, 42 instructions. It's only got 1K by 14-bit program memory. It's got a built-in clock, power on timers, watchdog timers, all the things that you need for mains operated equipment, really. So a wide operating range as well, up to 5.5 volts, and you can even run it at 3.3 if you wanted to. So yeah, pretty handy. We've got a 4-pin sort of connection through to the RF receiver, but actually in this case, we're only using 3 of the pins, whatever module they're plugged in. What else have we got going on? Well, we've clearly a line coming out from the microcontroller here through this resistor into the base of this transistor. I say base, it might be the gate, of course. The other end of this transistor is going off to one of these terminals just here. Underneath this is the relay coil. There's a reverse bias diode across that relay coil so that when it switches on and off, of course, we don't end up destroying our transistor. So this microcontroller doesn't need to do very much. In fact, I pieced together this really simple block diagram showing that the microcontroller simply receives data from the RF receiver. It's kind of passive in that it receives data from the button. So that's 2 inputs basically. And it has 2 outputs, one going to a transistor that drives a 12-volt relay and one going to an LED just to indicate its status. It needs power for all that, of course, and it actually needs both 12 volts and 5 volts. 5 volts to drive the RF receiver and the microcontroller, and 12 volts to drive the relay. We haven't looked at that part of the circuit, but it's coming up next. So here we go, the opposite side of the board. And this is mainly about power supply, to be perfectly honest, although up here we do have our little RF modules. So we can see the coiled up antenna and the crystal and some components on the other side. Here's the relay that we were talking about when we looked at the other side. So this is a 16 amp 250 volt AC relay, so pretty good, with a 12 volt oil. This black wire here is live, and obviously that's being switched, so that's great. But notice, of course, that it's only switching just the live, not the live and the neutral. The red wire here is the neutral coming in. This is marked up as a fuse, although it may also have some resistance. That would make a little bit of sense, I suppose. And just here, we've got our expected capacitors and things like that going with our bridge rectifier. Now, just here, we've got a device called an LN8K06. If I put up the datasheet for that, it's a buck converter. So, but this is designed to run directly off the mains voltage. So if we look at the grid voltage, down here, we can run from 85 to 380 volts AC, 250 milliamps on the output and various things. And there is a circuit diagram, an application diagram just here. And I'm pretty sure that we will find that the implementation they've done is pretty much identical to that. Thinking about the relay is at 12 volts. So this is almost certainly doing a step down to 12 volts. So just here we seem to have a second regulator circuit. I'm guessing that's either to 3.3 or 5 volts, and that will be driving both the little RF receiver over here at the top and also, of course, that microcontroller that we saw. I would probably say it's likely to be 5 volts. So here's our tiny little RF module, and I've put both sides of it on the same picture for you just to make life easy. On the left hand side we can see the 433 megahertz crystal and a tiny coil of wire for the antenna. On the right hand side we can see the IC, which unfortunately is missing its part number, and the board doesn't have a part number either, and that there's just a bunch of capacitors with it. Now I've had a quick look around to see if I can see kind of a drop-in replacement, and this is the closest I got. So this is a CY85 mini board, 5 volts. It comes in various frequencies, including 433.92 that we're interested in. This particular board is supplied without the antenna coil, and if you look on the other side, it's pretty much identical. Its pin out's identical. Its functionality, I suspect, is identical, and in fact it has around about the same amount of components on it as well. It's just a fraction different. Now I think it might be using an IC like this one. This is CY620R, and if you look at the price on that, you can see it's 10 cents each. But in some ways there's so few components, you kind of wonder why they didn't just actually put the main components on the board and be done with it. So this is basically, you have an antenna and you have the chip, and data squirts out to your microcontroller, and that's all that's happening there. You can get very similar modules if you're interested in playing with them for Arduinos and Raspberry Pis and things like that if you want, and you should be able to pick those up from Amazon or eBay or whatever for a few pounds or a few dollars in quantities of 1 to 3, something in that region. I'm not going to mess around trying to get different manufacturers' boards on the hope that they're decoding in the same way and all the rest of it. But there's nothing clever on this board. It's not identifying the receiver or anything like that. It just picks up all receivers of that frequency and shoves whatever data it finds out on that data pin. And the microcontroller has to just work out whether that data is for it or for something else. I've checked the output of the RF module and it is indeed dead. But to be sure, I thought I'd take apart a working one just to double check. Now, it's got loads of exposed high voltages, so I've put some tape on and a bit of plastic, and I'm connecting my scope through a high voltage differential probe, because although I'm actually only dealing with 5 volts or so, it's not isolated. So since I've got a clip on my ground lead for the scope, massive amounts of current would flow immediately to the scope ground. That would throw all the breakers in the lab and also potentially damage the scope and the equipment under test as well. So here are the 3 pins going through to our RF controller, and I believe this middle one is probably the data pin. In fact, we can see data on that as we speak. It's constantly talking, and that's a 5 volt signal that we can see there, by the way. We can single shot it, and then we can see our data coming in from that RF device. So it's definitely the RF device, I think, that's our problem on our dead one. But basically the microcontroller and the RFIC are talking all of the time. I don't think we're going to see any difference, unfortunately, when I trigger the remote control. Oh, there we go. So the signal drops out after the actual switch changes state, not before. It looks like I press the button and it immediately stops, but that isn't what's happening. It's actually doing a signal and then switching off for a moment. And I don't know whether that's the microcontroller asserting that line low, or whether it's actually that the RF chip decodes a packet and then actually puts a pause in to let it to let the microcontroller know that's the end of the packet. So there we have it. No repair this time, but hopefully it was an interesting, informative teardown. I'm truthfully not very happy with the reliability of these. 2 failing in about 8 years is too much. Now I can probably get an RF module and fix it, but in small quantities, yeah, it's really not cost effective. It's almost as cheap to get a new remote socket. If you want to see a bit more on the RF module and the Manchester code, I can perhaps get one and maybe play with it on an Arduino or Pi. Let me know in the comments. Anyway, I hope you enjoyed it. Please don't forget to subscribe, like, comment, share, all that stuff. And I'll see you soon. Bye for now.